how is everybody doing? Come on, very cool, very cool. So exciting. I think it's one of the most packed builder nights that we ever had in Singapore. And yeah, big shout out to you guys for coming, for hearing, and it's incredible to have such an inspiration. I think everybody until now know builder nights. And yeah, so just to quick overview, like Builder Nights is all about kind of like no shilling. We want to speak about technical narrative. We started with like 437. We went to like different kind of like layer 2 infra scaling, and we're very excited to also like have a lot of builders. How many developers do we have in the room? Yeah? Oh, cool. Nice, 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 nice. Very cool. So sounds good. Without further ado, I think we can get started. Big round of applause. Thank you so much, Vitalik, for coming here and speak about 437. And yeah, thank you so much. Always this light.
Sorry, the remote is too centralized. Come on, when's the transaction confirming?
Should be fine.
Is this thing like running on chain on Bitcoin Satoshi's vision?
There you are.
Okay. Okay. So great. So today we're talking about account abstraction and ERC 4337 and ERC 7702. So to start off, right, what is ERC 4337? So ERC 4337 is this culmination of a 10-year journey of figuring out how do we actually make account abstraction really work in the Ethereum ecosystem in a way that actually satisfies both all of the underlying goals as well as actually having the security and decentralization properties that we care about. So actually, attempts to do account abstraction in Ethereum started all the way back in 2015. So even when Ethereum launched, actually, for a while there was a plan to try to make the default wallet that users use be a smart contract wallet. And this was a serious expectation that we actually had for some amount of time. And actually, this was also the reason why we originally did not make logs cover ETH transfers between EOAs, because we figured that people would quickly switch to smart contract wallets, and smart contract wallets can just log everything. So at the beginning, the first account abstraction EIP was called EIP 86. And then after that, it was followed up by EIP 208. It was followed up by many more things. And the core problem that it was trying to solve is basically that Ethereum is very good at enabling all of this general purpose computation for the execution part of a transaction, right? So for the part of a transaction that like actually does things once the transaction is already approved. And what we want to do is we want to allow the validation part of a transaction to also similarly try to be general purpose. The specific motivating examples include, one, multi-sig wallets, right? So I've been talking like everywhere actually since 2013 about how multi-sig wallets are the future and like we all need to switch to them. Then two is a quantum upgrade strategy. Eventually, quantum computers will come. According to Metaculus, they'll come sometime in the early to mid 2030s. I've also talked to people who think that the Metaculus estimate is crazy, and I've also talked to other people who think that the Metaculus estimate is crazy. The problem is that they think that it's crazy in opposite directions. So, we need to be prepared for quantum. Quantum computers will break ECDSA, and so we will have to switch to some other mechanism. Number three is being able to change the key that's securing your account, right? So key changes are a regular thing. They're a basic feature of any kind of mainstream computer security. So like PGP keys have expiry keys in general, have expiry dates, and you're supposed to like rotate them out and switch to new ones because there's always a risk that over time a key gets leaked. Then key changes So multisigs, also custom validation conditions. So things like if you're sending a small amount of money, require 1 key. If you're sending a larger amount of money, require like 4 out of 7. So this is how the Ethereum Foundation wallet works, for example, right? So a whole bunch of these different use cases that try to implement more complicated logic on the validation step. So ERC or EIP 86 and 208 started doing that, and it started going down this rabbit hole, but then we started figuring out more and more of the actual security issues, right? So for example, one of the problems that we ended up finding only a couple years in, that's like a relatively subtle problem, is this problem that what if you have 1,000 accounts, and each of those 1,000 accounts, as part of their validation, they call into one particular contract. And then you have 1,000 transactions that look like they're valid, but then someone sends one transaction that flips a bit in that shared contract from 1 to 0, and then suddenly all 1,000 of those transactions get kicked out of the mempool. This is a pretty bad denial of service vulnerability, right? And so this motivated the reasoning that, hey, well, we actually have to restrict the storage slots that individual transactions can access during the validation phase. And then we discovered a couple of other things, and that's where eventually EIP 2938 came in a few years later. Then Ethereum was finally entering the final stretch of switching to proof of stake, and the entire internet was basically yelling at us and saying Ethereum is bad because we keep promising proof of stake and we keep never delivering. And so we felt like, okay, we have to like actually go all full cylinders and like actually get this proof of stake thing out there. Of course, as soon as we actually got close, the narrative immediately flipped to proof of stake being bad, but that's fine. That's how narratives work. So now Ethereum is proof of stake, and it's proven to be robust and decentralized for over 2 years, and that number will keep increasing. Actually, wait, today is which day? It's the 17th. Okay, so I believe like 2 days ago was the second anniversary of the merge. So happy birthday, proof of stake. So the point is that like we were busy on doing this whole proof of stake thing, which is very important so that Bitcoin maximalists would laugh at us less. Well, actually, no, it's important. It's important because it's good for Ethereum to stop consuming 0.25% of the world's electricity, and it's good for the chain to like actually have economic finality and be more secure and be more Litecoin friendly, and all of these benefits, and the other stuff is just a side benefit, right? So. The point is that we were busy, right? And so the change from an EIP to an ERC basically came about because we figured, okay, how do we actually keep moving account abstraction forward? Well, how about we basically give the task to a part of the community that is separate from the core developers. And so while the core developers are focused on the merge, we can actually keep improving all of this account abstraction stuff in parallel. We can launch it, we can iterate on it, and we can get it like really bootstrapped much more quickly in that way. And so that is part of where ERC 4337 came from. The other part of where 4337 came from is that at that time, there's been this community of people that were interested in use cases like letting applications sponsor transaction fees for their users, like letting people pay transaction fees in stablecoins or in whatever asset they have, right? So if you imagine, you are some merchant in Argentina, and like you have a restaurant, and then someone pays you 23 DAI for a meal, and then you decide that like you want to buy a coffee, and then you suddenly need to spend like 3.5 DAI for the coffee, but then guess what? You don't have any ETH in your wallet. Then how do you pay, right? So this is like another one of those things that somehow got into the label of being account abstraction. Totally not my fault, but it's in there, fine. And so there's this like growing range of use cases, and so later I'm going to call it the convenience side of account abstraction, right? So 4337 is like basically a combination of turning 2938 into an ERC instead of an EIP, so something that works as a higher level primitive rather than being directly a protocol feature, and features like paymasters and all of these other convenience related things that users want. So this is the history. Now, what are the goals of ERC 4337, right? So one is allowing users to specify custom validation functions. So I talked about this already. 2 is being friendly to decentralized mempools and not suffering from DOS attacks. So this is really the thing that is hard, right? If you're willing to be centralized, then like actually you don't need any of this, right? All you do is you just like have your smart contract wallet, and then you just like send 0 gas transactions, and then you give it off to like a builder somewhere, and then you know, like if the builder is worried about being DOSed, then like the builder can like KYC you with a phone number, and then like you just solve the problem and it's fine, right? Except for like the whole reason why we're doing this crypto thing in the first place. So if you actually want something that is open and decentralized, it turns out that there's actually a lot of pretty tough challenges. And then finally, extensions to support paymasters and also extensions to support signature aggregation, which is another one of those topics that I think is going to become more and more important over time. Basically, yeah, as more and more applications start involving snarks, snarks are crazy expensive, or on layer 2s, if you want to use BLS signatures to save data, then like it's in order to actually get the data savings, or in order to get the verification savings in the snark case, you have to do an aggregation step. You have to either add all the signatures together, or you have to make a proof of the proofs. And so you have to like have some mechanism for representing this idea that like end users come in with n signatures or n proofs, and then you make like one proof of the proofs that proves that those n objects existing, but without actually containing them. And so you save on either data or computation or both. So supporting all of this stuff at the same time is the goal of ERC 4337, right? And especially the DOS resistance requirements are one of the key reasons why ERC 4337 is hard, right? Basically, if you want to resist DOS attacks, you need to restrict what the validation phase of a transaction can do. ERC 4337 is the result of a decade of work figuring out how to build against these constraints, right? So there have been many, many instances of people coming in saying, oh, ERC 4337 is overcomplicated, let me figure out something much, much simpler in a hackathon, and then they build a thing, and then they realize, like, wait, for this to work, like you basically just require a centralized real layer, and then that centralized real layer themselves is going to have to KYC everyone, right? So, like, these are actually hard problems, and like it always inevitably ends up getting into the point where 4337 just is roughly the class of solutions that you get. So convenience versus security goals of account abstraction is something that I think about a lot as like a key categorization, right? So the security goals of account abstraction are the reasons that motivated me originally, right? So multi-sig wallets, quantum resistance, social recovery, changing keys, especially revoking keys. One of the newer things is wallets being secured by a trusted platform module. So you have passkeys, and you have SecP256R1 is the algorithm that gets supported by a lot of these, and EOAs or SecP256K1, which isn't. So security goals. Then you have convenience goals. Convenience goals are things like paying gas in ERC20s, sponsored transactions, automation, so like automatically making a payment every month. And then there's like interesting things that are in the middle, right? So for example, this idea of doing multiple operations in one transaction. This is actually a convenience goal and a security goal. The reason why it's a convenience goal is pretty simple, right? So who here has recently done a trade on just like any DEX? Okay, cool. We actually use DEXs. That's good. So in order to do a transaction on a DEX, at least if you're doing it for the first time, right, you have to sign 2 transactions. It's like step 1, you approve, and then step 2, after you've approved, only then do you actually get to send the transaction. This is annoying. So this is the convenience part. If you could do multiple operations within one transaction, you could just send one transaction, and it's much more convenient. What's the security part? The security part is that, like, basically this ecosystem has come up with an entire zoo of protocols that have basically said, well, this approval stuff is annoying, and so let's do a thing where you just like do a single approval, and then that approval is just like an approval for infinite value, and you try to approve as much as possible in one transaction so that after that you don't have to think about approvals. The problem is that if you do this, then you're trusting an ever-growing amount of code, some of which might have admin keys, you have no idea, and you're trusting that code with the ability to just like grab an unlimited amount of money from your wallet. This is bad. So, and then the other bad thing, of course, is that if approving is like a thing that users are used to doing, then what someone could do is like they could say, hey, you know, I'm going to do one of those things where I'm going to give you free airdrop tokens, except to receive those tokens, I need to verify your account. And to verify your account, you have to click approve. And then you click approve, and then you realize it just grabs all your ERC20s. So doing multiple ops in one transaction can prevent a lot of those things, and so it's also a security feature. But anyway, so what's the point of this Venn diagram? Two technologies that people talk about as, like sometimes I think talk about incorrectly as being like substitutes for account abstraction. One is multi-party computation, MPC, and the other is, you know, what used to be 3074, now it's 7702. And I think like this, like I think it's good, right? And it's important, but it's also important to understand why it's not full account abstraction, right? And basically, yeah, what you notice is that MPC by itself, I mean, first of all, like it cannot satisfy any of these convenience goals, right? And so the only thing that it's doing is it's satisfying the security goals, but then even within the space of security goals, it can't satisfy half of them, right? So basically because like an MPC wallet, it's like, okay, fine, you're MPCing in ECDSA, and that can give you multisig, that can give you social recovery. That will not give you a path to quantum safety. That will not give you a key revocation. That will not give you TPM compatibility. Now, if you have a trusted cosigner, it can give you granular access control, okay? So that's MPC, right? Then, if you think about 7702, it actually gives you all of the convenience features, but it still doesn't give you a lot of the security features, right? So it's important to remember like basically what some of these intermediate technologies can do, but also what they can't do, and therefore why actually getting to the finish line of ideal account abstraction is so important. So, okay, I mean, I guess I've shit-talked 7702 for 2 minutes, but you know, I'm a co-author, and so 7702 came about for a reason, right? So let's talk about what that reason is. So what 7702 does is it gives existing EOAs the convenience features of account abstraction, right? So basically everything in this, the right side of the Venn diagram, 7702 levels up EOAs to fit into that same standard. A key goal of 7702 is to allow the EOA ecosystem and the smart contract wallet ecosystem to proceed as one ecosystem as they start employing all of these convenience features. Right, so the intended explicit goal is that when, for example, Uniswap the UI upgrades to let you do a proven trade in one single transaction, the code path that enables that is exactly the same code path if you're coming in with a safe versus if you're coming in with an EOA. Right? Or sponsored transactions, same thing, right? Or like setting up some kind of social recovery, ideally also the same thing. So proceeding as one ecosystem, right? And ideally, yeah, the 7702 wallet code can just be smart contract wallet code, right? At the very least, exactly the same Solidity file. So if we do that, then we basically keep these two ecosystems together, and we level up the convenience side of the entire ecosystem to give people all of these features that we need. And then in parallel, we can keep improving the security features. We can keep making the security side of 4337 more and more viable, more and more secure, cheaper and cheaper. And then through upgrading or through conversion, like we merge the ecosystems at some point later. So this basically is the intended roadmap. So what are the next steps, right? So this is one of the ways in which I think about it. Basically, if you think about the two axes as being like one is functionality and the other is efficiency and compatibility with existing applications in the existing ecosystem, you can think of EOAs as being in one corner, and you can think about smart contract wallets as being in the opposite corner, right? And so either you have an EOA, and your EOA does not have these convenience features, it does not have these security properties, but on the other hand, if you have a smart contract wallet, which does have these properties, then your smart contract wallet, like, it has a whole bunch of other problems, right? So for example, if you have a smart contract wallet, you would also need to have an EOA that would do the paying transaction fees, and you would be incompatible with a bunch of stuff, and so on and so forth. The thing that 7702 does is it fulfills this short-term EOAs upgrades bucket, right? Basically, it moves EOAs up the functionality stack, and then that gives you the convenience, and then eventually we can have either an account upgrade mechanism, or potentially we can convince users to just switch accounts entirely. This is a debate, whichever one happens. Fortunately, we don't have to resolve it tomorrow. Then we can actually add the security features on top, and we can get to ideal smart contract wallets. And then at the same time, we can take account abstraction, and then we can start enshrining it, and we can start adding layer 1 protocol features to make it more and more powerful, and we could basically maneuver smart contract wallets into being the exact same thing as upgraded EOAs, and then eventually the only thing that we have is just very efficient and very powerful smart contract wallets. So this is look, the long-term goal here, right? So next steps, right? So EIP 7702, this is, of course, planned for Pectra, and it's going to be great, and EOA users will start getting access to really nice convenience features. I mean, definitely don't expect to be able to do one-click trades on Uniswap at like fork time plus 30 minutes, because I think this stuff needs to be developed securely, it needs to be deployed with care, and all of those things, but these kinds of functionalities will start coming online. At the same time, ongoing work on refining smart contract wallets. So there's this entire smart contract wallet ecosystem. There's a lot of discussions around doing modular smart contract wallets. What pieces can we standardize? How do we do more verification of all of the different pieces? So continued improvements on that whole ecosystem. In parallel to this, there's this whole conversation about enshrining like features of 4337 in layer 1. And this doesn't have to mean like literally taking all of 4337 and just turning it into a layer 1 feature, right? Actually, the 4337 team, so some people from 4337 team are here. Hi, Yoav. Say hi to everyone. So Yoav's already, Yoav and the team have already taken the original 4337 in turning into an L1 feature EIP and turned it into a collection of EIPs that put in specific features, right? And so you can take this piece by piece, and the specific value that you get by doing it piece by piece is basically one is that there are certain inefficiencies that are unavoidable when something is a smart contract, right? So for example, one very simple one is if you have a bundle, you have to load the code, you have to load a bunch of storage slots. This has an extra fixed cost of about 100,000 gas, and this is an expense. And the problem is that if you have a market that has a high fixed cost, then that adds market inefficiency, right? So that's one problem. Another problem is that there's been a lot of discussion around inclusion lists and around improving the Ethereum network's transaction inclusion guarantees so that users can reliably see transactions included, even if the builders become super centralized and the builders decide that they want to screw around with and delay certain people. And so in order for that to happen, what we want is not just EOA-based transactions, but also account abstracted user operations to be able to benefit from those properties. In order for that to happen, because inclusion lists are a protocol level feature, some portion of ERC 4337, the concept of validation execution separation and the ability of validation to be something that is a smart contract code needs to be enshrined in some form, right? And so this is also a bunch of work that needs to be done. And then the hope is that over the next few years, we can get to the point where the parts that really need to be enshrined get enshrined, and then we slowly work toward some kind of convergence toward an end state for this ecosystem. Making dApps more smart contract wallet friendly. This is super important for all the dApp builders out there, right? So there's a bunch of assumptions that there are some dApps and there are some protocols that I currently use that will stop being true in a smart contract wallet world. So one simple one is like there's some of these like permit ERCs. Well, one of the problems that they have is basically that they make the assumption that if you have a public key that hashes to an address, then that public key is authorized to control the address. Pretty simple, right? In an EOA world, this is guaranteed to be true. In a world where accounts can upgrade, this is not guaranteed to be true. And so you have to do things in a way that assumes that any wallet can become a smart contract wallet. So this is one example. Another example is lots of dApps require off-chain signed messages. And off-chain signed messages, there is an ERC for making them smart contract wallet friendly, which is ERC 1271. And then on top of that, there is another ERC. I forget the number. It's like somewhere in the high 6,000s. But the point of it is basically it extends 1271 to cover 6492. So I think you should just like think of 6492 as being part of 1271, right? So if someone ever says 1271, just like assume it includes 6492, right? Which basically extends it to cover like what we call counterfactual contracts, contracts whose code has not yet been deployed on chain, right? Which is a really important use case, right? Because like your account receives money for the first time before it sends a transaction for the first time, right? Because you need to already have money to send a transaction. So that's like dApps need to support that. There's also like certain conceptual changes. So for example, you can no longer assume that if you make a signature once, that signature will stay valid for the same wallet forever. And like that's fundamental, right? Because you want people to be able to change and revoke their keys. So there's a bunch of these changes. Another big one is like there used to be dApps. I think people have fortunately already stopped doing this, that assume that if an account has no code, then it's an EOA, and so it's controlled by a person. And they do this to try to like basically prevent smart contracts from interacting with their dApps, and like trying to do like soul-bound token type use cases or royalties type use cases and things like that. And that's something that unfortunately you'll probably just like have to stop doing and find some other way to do anyway. So all important next steps. Finally, a whole other rabbit hole is cross layer 2 smart contract wallets, right? So one of the things I talked about in a blog post last year is this idea of the 3 transitions. Ethereum ecosystem needs to simultaneously upgrade in 3 directions. One of them is security and convenience through account abstraction. The second is scalability through layer 2s. And the third is privacy through stealth addresses and various cryptographic protocols. Now, the challenge comes when you have to do multiple of these things at the same time. For example, if you have an EOA, that EOA is going to have the same address on every chain that has any version of the EVM. Actually, it doesn't even need to have the EVM, right? If you like literally just take Bitcoin and then you just swap out SHA-256 and RIPE-MD160 for Ketchak, and you swap out the address format, then like you would be able to have Ethereum EOAs on Bitcoin, right? Now, if you go to smart contract wallets, then like suddenly you might end up depending on, I mean, not just a full EVM, and like then there's like a difference between being EVM compatible and being almost EVM compatible, and so there's more of a premium on like actually having the full EVM. Then you have the fact that you have different EVM versions, and so if you have some EVMs that support EOF and others don't, then that creates an issue. And then finally, you are going to have chains where you're not able to guarantee having the same address on every chain, right? And this is like one of the motivations of the whole concept of chain-specific addresses, right? Basically that you make the address, like the human readable address, include not just the 20-byte account ID, but also include the chain, so L1 or L2 or whatever, that that particular account is living on. And then that address would be something that your wallet would just automatically give you. And then when you give it to someone, then they would already know, like this is the network that you're supposed to be sending them to. And then if they're currently on Optimism, but your wallet is on Arbitrum, then they would know, the wallet would know to do a cross L2 transfer instead of like trying to transfer on Optimism, right? And so the whole concept of like accidentally sending someone coins on Ethereum when they should have sent on Polygon will just stop being a problem, right? But in order for this to actually happen, then you actually need chain-specific addresses. Another big issue is if a user changes their keys, then you will need a way for those key changes to propagate across layer 2s. And for that, the short-term solution is basically making key change messages that are replayable. The medium-term solution is key store wallets. So the Scroll team has been working on this. A bunch of other teams have been working on this, where the key information lives on layer 1. And then the long-term solution is key store wallets, where the key change information lives on layer 2. So that's the kind of long-term roadmap there, right? But the whole cross-layer 2 discussion is one that's actually very tightly connected to the switch from EOAs to smart contract wallets. And then actually, if you start taking privacy into account, then you start talking about stealth addresses, and you start talking about how do we make key store wallets themselves be ZK'd, and there's a lot of really interesting stuff there. And so that ends up taking things even further, right? So there's still quite a long way to go. But I think also this year has been a really pivotal year for this whole ecosystem to really become much more mature, right? So we have EIP 7702 coming soon. We also have ZK email now on testnet, and soon will become available in wallets. So I know I've seen Sol Wallet has been integrating it. I've seen I believe OKX has been there's been a bunch of wallets starting to do ZK email, and I expect this concept of ZK wrapping institutional guardians, this also will be one of the big unlocks that makes the whole concept of multi-sig and social recovery actually really usable for regular users, right? So this year is a very good year for that. And I think it's particularly powerful because it creates this really nice spectrum where beginning users who are joining for the first time and users who are very cypherpunk and wants to hold all of their own keys, and users that wants to do things like me and have multi-sigs and do social recovery with various other individuals, can all be part of the same ecosystem and can all use the same dapps and all use the same wallets, right? So I think this is something that's really starting to become accessible as well, right? So really trying to be friendly to new users and at the same time being friendly to the values that make the crypto space be what it is at the same time, and really trying to do a good job of that. So this is where account abstraction is this year, but still a long way to go, and best of luck to all of us building to make that happen. Yeah.
So I think we have a couple of questions. So let's do just raise your hand. I don't know. Yeah. Let's go on the back here. You have, okay, perfect.
Yeah, hi Vitalik. First of all, I would just like to say thanks for all the jobs you've created. Everyone in Singapore is here because of you. My question is, instead of doing this on the base layer on L1, why can't we do this on some L2 and kind of try it out there, and then if it all works out, then come to L1?
It's a good question. I mean, I think my answer there is basically that the Ethereum ecosystem as a whole has some pretty powerful network effects, right? And we've seen examples of people trying to do their own layer 2 and make a wallets that target specific layer 2s, and basically say, we're going to create this sub ecosystem, and it just it feels like all the examples of that I've seen just end up failing, right? Because ultimately, people don't want to join Ethereum to use just your own 2 or 3 bespoke applications. They want to use the entire set of Ethereum applications. And so for that reason, you want compatibility across a broad range of layer 2s. I mean, I think one other version of this that gets brought up is should we enshrine 4337 in layer 2s first and then move it to layer 1 later? And I think that's something that can happen, right? I mean, there is multiple growing L2-focused teams in the Ethereum Foundation. There's the roll call group. There's a lot of people that have been really trying to do this movements to try to coordinate layer 2 EVM improvements together. And I think it's good to, it is good to do that, though at the same time, right, there's still a lot of stuff that lives on layer 1. And so, the nice thing about the 4337 approach is that if you do the enshrines thing on layer 2, but then you also just have an ERC on layer 1, or even if you have it enshrined on 5 L2s, but then everywhere else you have an ERC version that's maybe crappier, has worse censorship resistance, it costs twice as much, but at least you can use it, that's still already something that's much better, right? So I think there is a lot of value in actually bringing over the existing user base and all of the existing network effects, but some kind of staggered deployment is something where there's definitely a lot of value in it as well. I mean, one other argument that I think used to be strong but got a little bit weaker recently, right, is that the argument used to be that 4337 is expensive, so let's only use it on layer 2, where on layer 2 the fees are trivial, right? And what we've seen happen now is basically, layer 1 itself has gotten much cheaper, and then also layer 2's, the data has gotten cheaper, right? So actually the data computation balance on layer 2 has changed somewhat, right? And so it feels like it's just actually fine to even do some of this stuff on layer 1 more, and then hopefully by the time layer 1 really heats up again gas-wise, we'll actually have some enshrinement, and all of this stuff will be cheaper on layer 1 as well.
Hello, I'm Sasha, work for 1inch, and my question related to swaps, because we are here for the representing the swaps, and you shared the user experience for the smart wallets, and there was a long way for the swap. There was a P2P, DEXs, DEX aggregators, then DEX aggregators, Uniswap basically released their standard 7683, if I don't remember, and I saw your comments, and we've just released another vision, which is Atomic Swaps white paper, and I just want to see, and now I saw your talks, and I hear that do I understand correctly that you think that chain abstraction and basically interoperability between chains should be solved not through the any standards for the swaps or on the layer, on the layer net, I don't know, side? How do you see basically the swap future?
I mean, okay, I guess the two things that matter to me the most, right? One is standardization at the UX layer. I think no matter what, we need to have the property that you can take an address, that address contains an account ID and a chain, and you can put that into a to field, and then you can click send, and if it's on the same layer 1 and layer 2, then it does a regular send, and if it's cross layer 2, the wallet figures out whatever is the best safe cross layer 2 swapping method that's going to happen quickly, right? So that's the first part, right? So from a UX perspective, making within a chain and cross chain feel the same. The second thing that I personally care about is I believe that at the very least there needs to be some kind of fully credibly neutral, decentralized, no governance token, kind of backstop mechanism, so that it's just this thing that sits there and always provides a guarantee that there is at least this one way to do a trade that that any wallet will always be able to do, and that it will be able to do even 10 or 15 years from now, right? And then individual wallets can obviously optimize on top of that, and then individual layer 2s and layer 2 ecosystems can optimize on top of that, and you can create even individual swapping platforms. And I mean, I think to me, so the one benefit of the ERC 7683 approach in particular, right, is basically that it's extremely low infrastructure, right? Because as a user, all you need to do is just send a transaction on the source layer 2, right? You don't have to go and talk to any IP address. You don't need any off-chain peer-to-peer network. You don't need anything that can break, right? So that. So that's why I see 7683 as being a really powerful direction to go, especially for this kind of backstop. I mean, the atomic swap approach, right? It generally does involve some kind of off-chain communication, right? And I mean, I think if it's more efficient, then like that's fine, right? I think like wallets should integrate it, and it's wallets' job to try to give like the best experience and the lowest slippage to their users, right? And they should incorporate that, right? So like that's good, right? I want to see a world where users have you know, like the lowest possible slippage. I also want to see a world where, you know, like if some totally crazy thing happens in the world, and like, you know, like 2/3 of all the servers stop working, and then another 2/3 stop working because a bunch of companies shut down, the code that gets written 10 years ago should still be usable, right? So like, I think our ecosystem should be satisfying both of those goals at the same time. Yes, yeah, and thank you for all your hard work.
Thanks a lot for your presentation. Interesting as always. With account abstraction, you would get addresses that are specific for blockchain. Would that be negative if you, for example, send it on the wrong blockchain to that address?
Sorry, what?
The addresses that are specific for the blockchain?
Yes.
Would it be negative for you?
Would it be negative? Why? What do you mean? What would be negative?
Well,
Sorry.
if you have one address on Ethereum, but you send to that address on Arbitrum by mistake.
Right, sorry. So when I mean like chain-specific addresses, I mean the idea that like the address, so like the thing that right now is like 0x whatever, like that would contain both the account ID, which is what it is now, and it would also contain the chain, right? So from a UX perspective, like it would be like basically physically impossible unless you like start intentionally fiddling with digits. And like there's even ideas to make the chain ID be part of the check summing mechanism, and so like you would not even be able to edit it manually unless you go into Python or whatever. And so like from a user experience perspective, like you would just have this like one atomic object that just represents the idea of like this particular account on this particular chain, right? And so the whole concept of like sending to the right address on the wrong chain is not something that would like even be possible anymore.
Let's do a couple of questions there.
Yeah.
One there.
Yeah, test. So you had the slide about ERC 7702, where it's written, give existing EOA the convenience feature of account abstraction. But how can you ensure that EOAs have all the possible features that could exist? Because account abstraction is also, you have different type of smart wallets, you know, like Safe have multi-sig, then you have, you have probably many more. How do you solve that? How do you think about that?
Yeah, so 7702 was definitely meant to, so it gives the convenience features, right? Because what 7702 gives you is it basically lets you have something that is a smart contract wallet from the perspective of like an execution, but ultimately it's still controlled by an EOA. And so it cannot be more secure than an EOA, but aside from that, it can do everything, right? And so for that reason, right, 7702 is like, it just is by definition able to unlock whatever like convenience account abstraction features that you want. And the other thing that it could give you, right, is it could give you like a wallet that has a second key, right? So like, for example, you could have an ECDSA key that's inside of a hardware wallet, and then at the same time you can like authorize a second key, but then you can give it a spending limit, right? So like you could do things like that, but like ultimately the security is upper bounded by the fact that there is still one single key that controls the entire account. And so like that just is the fundamental limitation of 7702, right? 7702 is about increasing the functionality of wallets within that box. If you want to go beyond that box, then what you need is you need to either switch to another smart contract wallet today, or you need to like wait for potentially, like if the community decides to do it, a future EIP that would allow you to convert an EOA or a 7702 wallet into a full smart contract wallet.
Cool. I just want to mention something on Twitter side, like two things super quickly. What feature are important to you that make a wallet perfect? That I remember was quite viral. And the other thing is that you public mentioned the stage one, and I think like you want to expand on these two things because I think it's super interesting for the audience here.
Sure. So, features that make a wallet like great for me are, so first of all, right, I think I want to see a really good and very user-friendly implementation of the whole multi-sig and social recovery concept, and the concept of having different permissions for potentially different accounts, or at least different classes of assets or applications, right? So I want something so you know how when you go to Safe and you can set up a new wallet. One thing, why not, instead of just letting people put in Ethereum addresses, also let people put in an email address. Like you have Guardian number 1, 0x12345, blah, blah, blah. Guardian number 2 can be sirbobalot.eth. Guardian number 3 can be george@gmail.com. And then under the hood, it would automatically generate a ZK email address that is only controllable by george@gmail.com, right? And then you could do that for ZK email. You could do that for Anon at HAR. You could do that for ZK wrapped Minocard, basically any of these ZK wrapper institutional guardians, right? And then if you have, let's say, any one of these blockchain-based social media or messengers, whether it's Farcaster or Status or something else, then one other kind of even further goal is you should be able to just basically link your social to your wallet, and it would automatically suggest a set of guardians to you based on who your frequent contacts are, based on who actually maybe has had access to their account for a long time, and who actually has a wallet that you can link to. So the one implementation of social recovery I remember seeing in the wild outside of crypto, right, is WeChat. In WeChat's account recovery, it had this feature where basically in order to recover your account, you have to ask 2 of your contacts to send you a particular 6-digit code, right? And the reason why that account recovery works is because you don't have to manually choose who your trusted contacts are. It's just based on your existing contact list, right? So a really good implementation of social recovery that basically guides the user toward what choices make sense for a newbie, what choices make sense for someone with $30 million, and what choices make sense for someone who is very paranoid and wants to trust everyone themselves, and every kind of point in between, right? So that's feature number 1. Feature number 2 is everything I've talked about, cross-layer 2 user experience, cross-layer 2 compatibility. Number 3 is built-in light client. So use Helios to actually verify the Ethereum layer 1. So anytime you do a call, a balance get, even a transaction simulation, you ask for light client proofs, and then you use Helios and you actually verify them, and then you do that for layer 1, and then you also do that exact same thing for any layer 2 that exposes how its state root mechanism works. So that's number 2. Number 3, deep integration of privacy protocols. So if you create a new address and you move coins from one address to another address, the default way to do that move should be through a privacy protocol. If you have a wallet and within that wallet you have 5 different addresses, the wallet should treat that as being 5 different profiles that you are trying to keep separate from each other. This is not perfect, but I think less information is always better than maximum information, right? You want to try to look, we want to have as much control and as much choice over the flow of information and which information gets publicized and which information does not as possible, right? So that's number 3. Number 4 is, of course, all of the protection features around preventing scams, around preventing detecting thefts, detecting bad applications, that whole list of things, and done in a way that's maximally privacy preserving. And then number 5 is, I think this is another one of those things that's a little bit more far out, is instead of just being a MetaMask style thing that assumes dapps are in a browser, you actually try to fix the security flaws that are inherent in the concept of dapps being web pages itself, right? So when your dapp is a web page, you're grabbing the dapp contents from a server. You have no idea whether or not that server was just hacked 2 minutes ago and the entire dapp replaced with one that's going to steal all your money, right? So what we need at the very least is dapps need to have code uploaded to IPFS, and your browser should be fetching it from IPFS directly. Now, Brave does this, but the implementation is crazy slow, and so even using Brave, I end up using .eth.limo. So you want an implementation that's actually fast. And then also you want like full supply chain verification, right? So you want something where if you have some way of knowing, let's say I'm using Aave, then like you should be able to say, okay, well Aave is Aave.eth or whatever their .eth is, and then that .eth should itself directly control the IPFS hash, and so you would actually need like a DAO to approve every single commit to the UI, right? So you actually have this kind of chain of trust, and then if the UI was changed within let's say 24 hours, then like your wallet would even give you a warning of that. So like basically really have this strong end-to-end chain of trust for dapp interfaces, and then on top of that, like actually go in and start thinking about things like, oh, can we try to make a programming language to try to make dapp UIs automatically like more guaranteed to like actually do what the user intends to do. Then we can think about privacy protection, right? So basically attempting to access an outside server should be viewed as a sensitive operation in just the same way as sending a transaction should be viewed as a sensitive operation, right? Okay, so like there's basically this like really far rabbit hole that I think you can go if you want to create an ideal wallet, and I would love to see people like like really try to take this challenge on. So thank you.